think I was muted. This is the FSA practice test for the Florida Algebra 1 end of course exam. And I will go over some of these questions and what kind of strategies you can use to answer them if you have no idea what to do. So for this first one, Jeremy determines that the square root of 9 is the same thing as 9 to the 1/2. So what's the square root of 9? It's 3. So we know that when you look at all of these answers here, they're all equal to 3. Okay, so what goes in this missing line here also has to be equal to 3. If I look at my answers, I can eliminate some of them that don't equal to 3. So the first one, A, is 3 squared, which is 9, and 9 to the 1 is just 9. So this is equal to 9. So we know it's not that one. 3 to the 1/2 plus 3 to the 1/2 is the square root of 3 plus the square root of 3, which is not equal to 3. That's like 2 square roots of 3. That does not equal 3. So C is 3 times 3, which is 9 to the 1/2. So this does equal to 3. And D is 3 times 3, which is 9 to the 1/2 plus 1/2, which is just 1. And that equals 9 to the 1, which is 9. So that is not the answer either. So the only one that it could be is C, because that's the only one that's equal to 3. For this next problem, a bird drops a stick from the top of the Miami Tower. The height of the stick after X seconds is given by f of X equals 625 minus 16x squared. So the height is 625. Like that's how high it is when it's dropped. When it hits the ground, the height's going to be 0. So select all the correct interpretations. All means there's going to be more than one answer. So select all, more than one, the correct interpretations of the coordinates of the point at the maximum. So maximum means the highest point. And we know that the highest point is 620 feet high where the bird drops the stick from. So for A, it says the time it takes the stick to hit the ground. Well, hitting the ground is at 0. So that is not the maximum height, right? The time when the stick is at its highest point. Highest is the same thing as maximum. So B is one of our answers because highest is the same thing as maximum. Okay, the height of the stick when it is dropped from the Miami Tower. So when it is dropped, that's also at the highest point or the maximum. So C is also an answer. The time when the stick is dropped from the top of the tower. So from the top is also at the highest point or the maximum. And the distance of the stick from the Miami Tower when it hits the ground. So hits the ground is equal to 0 or the lowest point. So that is not an answer. So for this one, it would be B, C, and D. Okay, so for number 3, some of the steps in Rhea's solution to 2.5 times 6.25x plus 0.5 equals 11 are shown. And it's not asking us to fill in all of the steps. It's just asking us what would go in the last one in 4 where the question is, right? right here. Okay, so select the correct reason for line 4. And on the left is the statement, or like the problem being solved, and on the right is the reason, like a geometry proof. So if we're looking at this problem, um, you could, like, say the first one, you could either divide 2.5 over to the 11, or you could distribute it. So either way, you're going to be left with, something times x plus something on the other side. So I'm just going to put like, um, oops, I need to turn that off. Okay, so something x plus something equals something. And then after that, we're going to subtract whatever this is to the other side. So then I have something x equals something, and that was the subtraction. So now I'm left with something times x, and I'm going to have to divide. So to get the x by itself. So this one should have, the last step should be divide. So the answer would be division, property of equality. For number 4, we have a table, and we have to fill in the little grid for our answer. So Cora is using successive approximations to estimate a positive solution to f of x equals g of x, where f of x equals x squared plus 13, g of x is 3x plus 14. So we have two different formulas, f of x and g of x. So, and we want them to be equal to one another. Um, so the table shows her results for different input values of x. And using this process, find the positive solution to the nearest tenth of f of x equals g of x. So if I were to put, say, f of x, and the formula is x squared plus 13, and over here, I'll just put g of x, and that's 3x plus 14. So if I look at the table, what's already done, I can see at 0, it was 13 and 14. So this is kind of close. At 1, it's 3 spaces away. 17 minus 14 is 3 spaces. At 2, 20 minus 17 is also 3 spaces. And at 3, it's at 1 space. At 4, it's at 3 spaces. And then because between 3 and 4, it looked like at 3, it was pretty close. So Cora did 3.5, which is 0.75 away. So we know that we're getting in the range, right? It's got to be somewhere between 3 and 4. And at 3.5, it's at 0.75. So we could either pick a point like 3.6 or 3.7, or we could pick a point below 3.5, which is what I'm going to do to try to figure out, because I'm guessing that it's going to be lower than 3.5, because the closer you get to 4, the bigger the difference is going to be. So if I were to choose 3.3 or 3.2, let's see how that works out. So if I were to plug in, let's say 3.2, then I could say 3.2 squared plus 13, and 3.2 times 3.2 is, let me see, 10.24 plus 13 is 23.24. If I plug in 3.2 over here, 3 times 3.2 plus 14, so I'm going to get 9.6 plus 14, and that should give me the same thing, 23.24. So the answer would be 3.2, and I would need to fill that in on the little graph and make sure I got all my bubbles filled in good. On the computer, it would be, just type in your answer. So if I hadn't picked it correct right the first time, like I would just keep plugging in numbers to see which ones would give me the same answer, and then go up or down based on that. Okay, so for number 5, it says the system px plus qy equals r and fx plus gy equals h has a solution 3, -1. So 3, -1 is a point. We have 2 lines, and they cross at the point 3, -1. So we don't know what all these numbers are, and we don't really have to guess what the numbers are. It wants to know what other systems would have the same solution of 3, -1. So what we're looking for here is more than one answer because it says select all. So that means there's going to be more than one answer. And what I need to do is make sure that we're not changing anything from the original system up top to these systems down below. So it has to be like a consistent change. So if I look at A, for example, the second equation, fx, right here, the second equation, fx plus gy equals h, is the same thing as the equation up there, right? These two are the same. And if I look at the top one, px plus qy equals r, and look at this first one, it has p plus f, q plus g, r plus h. So basically they're just adding the f, g, and h from the second one, and that's pretty consistent. So A would be one of the answers because you're changing it consistently across. If we look at B, remember to keep in mind we're looking for like consistent change. The first equation has a change in it, and the second equation has a change in it, so that is not consistent. The change would have to be only to one of the equations. So B is not one of our answers because of this and this and this. The change would have to be to both like only the first equation or only the second equation. So B is not one of our answers. If we look at C, remember we're looking for like a consistent change all the way through. So the first equation, px plus qy equals r, is the same. And if we look at what they did to the second one, let's see, 3p plus f. So they're adding 3p to it, and then 3q plus g, and then 3h plus r. That is not consistent because they are multiplying like 3 times P, 3 times Q, which are the top two things. And then here, instead of 3 times R, they multiplied the 3 times H. So because they didn't multiply the 3 times R, that is not consistent. Looking at D, let's see, we have Px plus Qr or Qy equals R, that's the same. And then for the second equation, we have F minus 2P, so that's 2P from the top equation, G minus 2Q, so that's 2 times Q from the top equation, and then H minus 2R, and that's 2 times R from the top equation. So this one is consistent all the way through. So D would be one of the answers. And for E, the Px plus Qy equals R is the same as the top one. And down below, they multiplied every term by 5. So 5fx plus 5gy equals 5h. So that is consistent. They multiplied 5 by everything. So E would also be an answer. So for this one, the key is to look for consistent changes all the way through to all of the terms in one of the lines instead of like the mismatched, like this, and this don't match, okay? And this, and this don't match, but all the other ones do have consistent changes made. Okay, so here we have a parabola, and we're given a formula, and it says X is the number of balls produced in one day at a toy company. So in thousands, and the company wants to keep the production cost at or below $125,000. So see this, the dotted line that is horizontal, that's at $125,000. So we need to make sure that the cost is at or below that. And I'm going to scroll down just so we can see the answers. So right here's the line, and we need to keep the cost at or below that. So obviously we're not going to have a negative cost. So it's going to start at 0. So let me actually, so we're looking at, I'm going to pick a better color. We're looking at this portion right here and this portion right here that I'm highlighting in yellow, okay? So how would we write that? Well, so the first portion is going to start at 0 because you're starting at 0 for cost, you're not starting at a negative cost. And the only answer that starts at 0 is D. So I know that's the answer, but I'll explain it a little bit more. So from 0 right here all the way to 2.6, which is right here, is one of the things. And then from 2655 right there all the way to 3238 is the other section, moving from left to right, like along the X values is what we're looking for. So that would keep the production cost underneath this line right here. Okay, so for number 7, we have a system of equations and we're looking for a solution. So anytime you have systems of equations, there's a few different ways you can solve them. Um, what I'm going to do is get the we could substitute, or we could get rid of something. So since the second equation is 5y equals x plus 6, I could substitute in for y, or I could substitute for x. Um, if I were to subtract 6 to the other side, then I would have x equals 5y minus 6. Now I can plug this whole part in, 5y minus 6, in for x and the other equation, okay? So if I plug 5y minus 6 in for x, it would look like this. 5 times x, or 5y minus 6, plus 2y equals 24. Now my next step is going to be distribute. So 5 times 5y is 25y. And then 5 times negative 6 is minus 30, plus 2y equals 24. Now I'm going to combine like terms. So 25y plus 2y is 27y. Minus 30 equals 24. Now I'm going to add 30 to both sides. So 27y, adding 30 cancels it out. So 27y equals 24 plus 30, or 54. And then I'm going to divide both sides by 27. So y equals 2. I know that y equals 2. Now I want to figure out what x is. So if I plug in 2 for y, then I can solve into either of the equations. Then I can solve for x. So let's say I have the x equals 5y minus 6, and I plug in 2 for y. So 5 times 2 minus 6, or 10 minus 6, so x equals 4. And I want to make sure that I don't switch my um, values here. X is 4, so I'm going to look to make sure I'm putting the right thing in the right one. So x is 4, and y is 2. Okay, sorry about that. I had to take a sip of water. So that was the end of part 1. Now we move on to part 2. Usually for tests like these, you get to use a calculator for one of the parts and not the other part. Um, I think that was the non-calculator part. This one should have This one says you can use calculators, and if you're taking on the test, they usually have a calculator like within the system on the test for you to use. Okay, so for number 8, we're answering two parts, A and B. And it says Sue removes the plug from oh goodness, this is why I teach math. Trough to drain the water inside. The volume in gallons in the thing that holds water after it has been unplugged can be modeled by 4t squared minus 32t plus 63, where t is time in minutes. And it says select the correct property that will give Sue the amount of time it takes the thing to drain. So we want to know if it's drained, there's no more water left, right? So what would that have to be equal to? If there's no more water left, if we set it equal to 0, then we will know how much time it took to drain. So the answer for this first part is 0. If you set it equal to 0, then you can factor it and figure out the time, which is t. 0 is if there's no water left. Does that make sense? Like, so if you set it equal to 0, then you could figure out the time. Okay? I don't have to work it out, but not for that part. Now, for B, it says select the expression that will reveal the property. So now we are going to factor it, okay? And there's a trick to factoring this expression. So it's not going to be A because it says select the expression and A has zeros in it. So it's not that one. You could, if you had no idea what to do, you could multiply these out to see which one is equal to the same thing here. But I'm going to actually show you how to factor it, just so you know. Because there's a 4 in front of the first term, 4t squared, we will have to try two different ways. So anytime you have, okay, I'm going to draw this twice. So 4t squared could be 4t times 1t, right? 4 times 1 is 4, and then t times t is t squared. Or it could be 2t times 2t. So 2 times 2 is 4, t times t is t squared. Okay? So that's the first part to factoring it, is looking at what could be this first term. The second part is what will multiply to give you the last term. So if we have 63, what are our different factors for 63? There's 1 times 63, 3 times 21, and 7 times 9. So I could plug in, well, I'm not even going to bother with this one because that's not in the answers, right? We don't have 4t times t in the answers, but we do have 2t times 2t right here, okay? So I'm going to check to see if this one factors out right. So let's say, so we're using the 7 and 9. One other tip with factoring is to look at your signs. So we have a negative 32 and a positive 63. So that means they're going to add to give a negative number, and it's going to multiply to give us a positive number. So that's why it's a negative and a negative, because a negative plus a negative is negative 32. And -7 times -9 is positive 63. So to test this out, um, let's see, we have, if we were to FOIL it, first times first is 4t squared. 2t times 2t is 4t squared. And then outer times outer, so 2t times -9. Oh, wait. I just wrote down 9 because I said 9. So 2 times 9 is -18t, and then inner times inner, so -7 times 2 is -14t, and then last times last, -7 times -9 is plus 63. So if I were to simplify that, -18t minus 14t is -32t, and that does check out. So our answer is B. Okay, so for number 9, we have a comparison of Florida and Texas. And it says the mean population for Florida. Okay, first of all, let's go over some vocabulary. Mean is the average, right? So you add up all the people and divide by county, and you get 291,000. I'm not going to say the whole number. And the standard deviation is this, the 467,000 number. So that's like how far from the middle it is. And the median is, if you were to line up all of the numbers from smallest to greatest, the median would be the number in the middle. Okay, so for Texas, the mean or the average population by county is 104,000, and the standard deviation is 374,000. The median or number in the middle is 18,000. So some of the data for both states are shown, and we have smallest, first quartile, median, third quartile, and largest. Now, we know that the median is the number in the middle if you line them up from smallest to greatest. The quartile is basically, this is how I would explain a quartile, okay? So if I were to have the numbers, let's say 0, 1, 2, 3, 4, 5, 6, 7, 8. I squished my 8 in there. Okay, so the median is going to be the number in the middle. These are already lined up from smallest to greatest. So our median is 4, right? That's the median, okay? So if I were to look at the numbers on, like, in between 0 and 4, 2 are really right in between 1 and 2. Like, right there is going to be our first quartile, quartile 1. And then right in the middle here is going to be the third quartile. I'm just going to put quartile 3. Okay, so your median is like right in the middle, and then your quartiles are like when you split that evenly. Okay, so a business moves its corporate location from Texas to Florida, and over 8,000 people move from the largest. So we're subtracting our 8,000 number from here. So this is getting smaller. And they're moving to the smallest Florida county. So we're adding the 8,000 whatever here. So this is getting bigger, okay? And it says select all, so more than one, More than one answer, select all the population statistics that will be affected by this population change. All right, so I got to scroll down. Oops. Let me clear the drawings and scroll down. Okay, so we have the interquartile range of Florida. We want to know if that's going to increase, decrease, or stay the same. So for Florida, remember your numbers are listed from smallest to greatest. And from the first quartile here to the third quartile for Florida, remember this is Florida and this is Texas. That's not going to change at all because the number that's the first quartile and the number that's the third quartile isn't affected because we're only adding to the smallest thing. So this one, the interquartile range of Florida stays the same. Okay, so for the mean of Texas, we are adding up all of the numbers for Texas because mean is average, right? So you're adding up all the numbers, and Texas now has less 8,000 something. So their average is going to be lower. It's going to decrease because over 8,000 people are gone or taken away. So if you add up all of the Texans and divide by the total number of counties, it's going to be lower. The median of Florida, that's the number in the middle. If you line them up from smallest to greatest, the number in the middle is not going to change. So that one stays the same. And the standard deviation of Texas. So that, just like the mean, is also going to go down because you took some away, and standard deviation, you have to like use the entire population, which is now smaller. So that has also gone down. Okay, so here we have a graph which shows the number of acres in millions of farmland in the US from 75 to 2008. And which statement describes the average rate of change? So if we look at the graph, it has a negative slope, it's going down, meaning that there's less acres of farmland from 75 to 2008. So let's look at the answers here and see which one is the best description of this graph. A says the number of acres of farmland in the US decreases by 0.21 million to 0.21 million each year. So is it 0.21 million? Over here on the left, it says acres and millions. So it looks like it goes down 20 million per year. Let me see if I can highlight like from here to here. Oops. Like the amount that it's going down is 20, and it's 20 million, not 0.21 million. So A is not, and A is not the correct answer. It's going down 20 million per year, about estimate. Not per year, per every 5 years, because from 75 to 80 is 5 years. So if I were to divide about 20 million by 5, I would get around 4. So it could be B. Let's look at the other ones. The time it takes the farmland in the US to decrease by 160 acres is 33 years. Well, no, because this is acres and millions, not just acres. So the answer is not C. And my drawing gets all messed up when I scroll. And then D says every 5 years, the amount of farmland decreases by 20 acres. That's also not correct because it's in millions, um, not just acres. So the correct answer is B. That's the only one that most accurately describes it. Okay, so for number 11, the points on the graph show the population data in millions of the state of Florida for each decade from 1900 to 2000. The data are modeled by the function p of x equals that big number times 1.43 to the x shown on the graph. So this is an exponential function, which is why it curves up steeply. And the population up and down is in millions, and the decades are on the bottom. So that's like every 10 years, like 1 is 10 years, 2 is 20 years. And it wants to know the domain. So remember the range is up and down, or the y values. The domain is left and right, or the x values, okay? And it gives us our options down here. So it starts at 0. Let me get, I'm not drawing. It starts at 0 right here. And where does it end up at? It looks like it goes up to 10, right? Like it looks like there's like a asymptote right there. That's like a line that'll never be crossed. So it starts at 0 and it goes up to 10. And that would be our domain because we're using the values that are on the graph. So from 0 to 10. So the answer would be D. Like 0 here, anything along the line, and then less than or equal to 10, which is like where this yellow line is. Okay? That's just for this portion of the graph that they're asking for. Okay, so this should look familiar. We had this problem earlier, I think. Um, a bird drops a stick from the top of the Miami Tower. The height of the stick after X seconds is given by this formula. F of X equals 625, which is the height, minus 16X squared, and X is the time in seconds. What is the maximum value of F of X? So remember, the maximum value is like the height. So if you're to plug in 0 for X, your height would be 625. So that would be your answer. So the maximum value of Y, like think of it on like a graph where this is Y and this is X. So you want to know like the highest point of Y. And that would be before the stick falls, right? So if I plug in 0 for X, it would be 625 minus 0, or just 625. Okay. Oh, and f of x, just in case you're wondering, is the same thing as y. Okay, number 13. A librarian in a large city collects data about summer reading program. He collects data for 2 years, 2011 and 2012, on how many books are read each week. The ordered data sets are shown. The librarian writes a summary about his data as shown. Choose the correct word or phrase to fill in each blank in the summary. For each blank, fill in the bubble before the word or phrase that is correct. So let's look at this first statement. If you compare the means or the average, it appears that in 2011, is it fewer or more books were read on average than in 2012. So in order to know that, we have to add all these up and take the average. Okay, so if you add up all of the numbers, and remember you can use a calculator for this section. So if you add up all of the numbers in 2011, I am just adding up the first 2 digits because I'm being lazy. I get 379. And if I divide that by 6, because that's how many numbers there are, then I get 63. If I add up the same way on the right for just the first 2 digits, oh, I also get 379. So being lazy did not serve me well. Okay, so let's do it the long way. 44,126 plus 44,901 plus 55,000 plus 58,546 plus 79,984 plus 99,860. And then I get like a 382,497 divided by 6 is 63749.5. Okay. If I say the numbers out loud, it's easier to put them into the calculator for some reason. 35,001 plus 41,534 plus 68,550 plus 75,534 plus 76,617 plus 84,834 divided by 6 is 63678.3. So if I subtract these, it's going to be 749 is bigger than 678 by about 71. So 2011 is approximately 71 more. So the answer for this one is B. All right, let's look at the second part. When the medians for 2 years are compared, the data shows, so the medians, remember the median is the number in the middle, kind of like the curb that's in the middle of the road. It looks like these are already listed in order from smallest to greatest. There's 6 numbers So the median is going to be like the average of the two in the middle. And if I were to get the median for the year 2011 on the left, it's 55,080 plus 58,546, and then divided by 2. And my median is 56,813. If I were to get my median for 2012 on the right, 68,550 plus 75,534, and then divide by 2, I get 72,042. So the median of 2012 is greater than the median for 2011. And it's going to be not 71, but about, I would say, approximately approximately 15,000 fewer. Okay. I have to erase some of this because it didn't scroll nicely. So the answer for the second part was this one. Approximately 15,000 fewer from 2011 to 2012 for the median. Now for the last little bit, as far as the spread of data, both data sets have the same what. So we have our choices of range, right, range, lower quartile, upper quartile, and interquartile range. So the range is if you subtract them both, like you subtract the largest number minus the smallest number. So that would give us the range. The lower quartile is, I'll show you on the chart, but I got to scroll back up to it for the quartiles. And then the interquartile range, I can also show you. So range, lower quartile, upper quartile, and interquartile range. Okay, so there are 6 numbers here. And the median is right here. So this is the median, okay? This is, I'm going to say quartile 1 or the lower quartile. This is like right here. This is the upper quartile or quartile 3, the third quarter. And then the range is when you subtract these, the big one from the little one. Okay. So just to give a quick look, the range, if I were to say like 99 minus 44, that would be 55. Okay. So I'm going to make myself a little chart and put range. So this is just estimate, 55. If I were to say 84 minus 35, that would be, I can't think. 84 minus 35 is 49. So that's nowhere near close. So we know it is not going to be range. Okay, we're looking for values that are the same. And then the second question was the quartiles. So if we look at the number, I'm going to highlight right here. That didn't really highlight. Hold on. If we look at the numbers for the lower quartile or quarter 1, One of them is 44 and one of them is 41. I'm just looking at the thousands, so I'm trying to draw with my eraser. Um, those are not the same. So for quarter one, that's not going to be your answer. Same thing for the second upper quartile or quartile 3. One of them starts with the 79, one of them starts with the 76. So that is not going to be the answer. So by default, the interquartile range, which means we're going to do quartile 3 minus quartile 1. So if I were to say do 79 minus 44, and I'm just estimating here, for the first one, I would get 35,000 something. Okay. So if I were to do 76 minus 41, I would also get 35,000 something. So the interquartile range would be the correct answer for this problem. So that would have been D, interquartile range. All right, number 14. Magda and Nicholas each purchased almonds and cashews for their trail mix. Yum. And here is the data in a chart and what's the cost per pound of almonds and cashews. So we can make a little formula for each one of these. And I'm going to use A for almonds and C for cashews. So if I were to say 6 almonds, 6A plus 1 cashew equals 73.60 for my first line. And then 4A plus 3 cashew equals 78. And that is the data from the second line. So all I've done is taken, like, basically made this into an equation, right? Or systems of equations. Now we need to either substitute or eliminate something, and I'm going to choose elimination because for this one, I think that that would be easier. So it looks like it would be easier to get rid of the C because one is 1C and one is 3C. I'm going to multiply the top equation, the whole thing, by 3. So if I were to rewrite that, multiplying everything by 3, 3 times 6 is 18. 3 times C would be 3C. And then 3 times 73.60 is, oops, 220.8. And then the second equation, I'm going to subtract. So minus 4A minus 3C minus 78. Make sure I do like consistent all the way through. I multiplied everything by like a -1. Now I can simplify. So 18A minus 4A is 14A. And 3C minus 3C cancels out. And then 220.8 minus 78 is 142.8. And then I'm going to divide both sides by 14. So A, or almonds, is 10.2. Okay, so I can put that in to my little bubble thing over here. 10.2. 2. Now that I know the price of almonds, I can plug that in and get the price of cashews. So I could plug it into either formula. I'm just going to plug it into the first one. So 6 times A is 10.2 plus C equals 73.6. So if I multiply 6 times 10.2, it's 61.2 plus C equals 73.6. And then I'm going to subtract 61.2 from both sides. So this cancels out and C is equal to 12.4. So C for cashews, 12.4. Make sure you're entering your answers in the correct spot. I know it's pretty common for people to accidentally put the cashews for almonds and the almonds for cashews. So double check to make sure that you did your answers where they're supposed to be. And that is solving systems of equations by elimination. And that is the end of this practice test. Let me know if you have any questions or if you want more practice, and I hope this was helpful.